Testing, testing. Testing the stream audio. Testing the stream audio. Testing the stream audio. Testing the stream audio. Testing the stream.
Without further ado, then, let's get into it. Big round of applause for Rohan and Rauno.
Hey, everyone. Okay, thank you. Can you hear me? Is that cool? Okay. Yeah, so I'm Rohan. This is Rauno. We're going to be presenting on implications of continual learning for language model agent capabilities and safety. So first, we'll just introduce ourselves a little bit. So I'm Rohan. I founded an independent research group called Ether. We focus on large language model agent safety. And yeah, I've been working on this with Rauno and another collaborator since about May of last year. I'm also a PhD student at the University of Toronto with Zhijing Jin as my supervisor, and started there in September, which is why I moved to Toronto. And before that, I did an undergrad at Columbia, where I studied computer science and math, and did a few different AI safety research programs like maths and the CHI internship. And yeah, I'll let Rauno introduce himself as well.
Yep, I'm Rauno. I've been working at Ether with Rohan over the past 9 months or so. And yeah, before that, I did a bachelor's in computer science at TU Delft in the Netherlands, and also various AI safety programs, including maths.
So as a brief outline of what we're going to be talking about today, we're going to first give a brief introduction to AI safety as a whole, then move into continual learning and both its capabilities, implications, and its safety implications, along with some angles of attack for how we can make it safer. So at a high level, continual learning is a topic that we're just getting interested in, have been exploring on a conceptual level, and think is very important for AI safety, as we will explain in the next slides. So before getting into continual learning itself, to give like a higher level introduction to what we work on and why, as I said, Ether is a large language model agent safety research group. And the reason we're interested in this whole topic and a large focus of trajectory labs as a whole is that artificial general intelligence and superintelligence seem to many, including us, like they may be among the most important events in human history whenever they come around. Intelligence seems like a very major factor in why humans are able to shape the world so much, and building machines that are more intelligent than humans, more capable of shaping the world and influencing it, could really change how we shape the future as a whole and what the future looks like. And it seems really important to have that push towards the best possible outcomes and to avoid the worst ones. And there are a bunch of different ways that things can go wrong here. So this figure is from a paper from 2023 kind of outlining various risks. So there's risk from malicious use from bad actors, from race dynamics between different companies and countries, from poor organizational management of these risks, and also from rogue AIs, where the AIs themselves are misaligned with human values and pursuing different interests. And all of these are important, but primarily at Ether we've been focusing on risks from rogue AI. As for the focus on LLM agents, which is a very major paradigm today, there's no guarantee that will result in AGI, but they are progressing very rapidly, and a lot of people are working to overcome their current shortcomings. So we think that they may result in AGI soon, and therefore it's worth putting a lot of effort into making sure that if they do, they're going to be a positive impact on society. So some major uncertainties that we have about whether or not AGI will go well include all of the ones listed here. So I mentioned race dynamics between countries and AGI companies. The more race dynamics there are, the faster things are going to go, and the less time people will have available for kind of managing those risks and taking their time to really develop things safely. So this seems like a major factor. Some level of cooperation would be ideal to reduce those race dynamics. Then another major uncertainty is kind of the extent to which reinforcement learning will be used in ways that enable opportunities for reward hacking and goal misgeneralization, which could significantly increase the risks of misalignment of LLM agents. Then something that we focused on for a lot of the past year was kind of how much hidden serial reasoning will AGIs possess. And this is around like chain of thought monitoring research is relevant here. And I guess we're transitioning away from that a little bit, but the more reasoning that models can do, that agents can do without us being able to observe them, the more likely it is that they can cause a lot of harm without us being able to intervene. The next two are closely related to the topics of this presentation on continual learning. And the first is, how much can we accelerate or automate AI safety research itself with AI? Since AI is kind of this tool that we're imagining is going to kind of change labor across the board in all industries and all cognitive fields, it would be great if we could apply AI itself to help us solve the risks associated with AI. And there's something like seemingly kind of circular, and I think I used to have this intuition that this isn't easy to do, but it's already happening to a very significant extent. You can really use AI right now to help you run experiments for AI safety research. There's still a question of which parts of the safety problems can be solved with AI and which ones can't, and that also seems like a very important factor in our ability to handle these risks. Then there's a question of what happens if AIs deeply reflect on their goals, which is not something we're seeing so much right now. And yet, it seems like it is a major factor in how humans approach decision making, and it shapes humans' values a lot to reflect on their own goals. So maybe this comes to agents that are doing longer horizon tasks and more open-ended tasks, that they have to think a little bit more about what sub-problems they want to tackle, what sub-problems they want to abandon, and maybe this level of reflection could arise as a part of that process. And lastly, outside of alignment, even if we have aligned AGIs, there's a question of what it would take to produce really great futures, which I think is also super important to consider. So all of this is high level, but we're going to zoom in a bit on those underlined too. And finally that was the wrong direction. Finally I'll get into continual learning itself. And let's start with just an introduction of like, what do I mean by continual learning? So I would say that an agent is an effective continual learner to the extent that it undergoes ongoing and persistent updates, learns new capabilities efficiently from those updates, and doesn't catastrophically forget existing capabilities in the process. I'll kind of come back to these ideas, but I think since humans undergo continual learning all the time, we have a large source of very intuitive examples, so I'll kind of use those to illustrate what I have in mind for continual learning. So some forms of continual learning are very deliberate. Humans kind of reflect on their own experiences and learn from those based on things that they actively, consciously notice. So one example of learning from reflecting on your past successes, which is something I took from my own life. Like I did this one time. I noticed that like I had been working on a side project for an hour every day. I'd set aside this time, and I really felt happy with how this went. I thought that I enjoyed it a lot, and I made consistent progress, and I ended up finishing this project, and I was pretty proud of it. And then I was like, okay, how can I kind of apply this insight to the future? And the thing that I did is like, yeah, I should just like do this more. I should do this daily hour thing again. And so I also have a weekly review template. So every week I like go through it. And I thought, okay, let me add to this weekly review template to remind myself every week to think about what project I want to work on for an hour every day. And yeah, I think that also worked pretty well. I was able to then like apply this technique again more times. Not all the time, but still, I think this is like an example of me reflecting on a like past successful thing that I did and being able to like learn to repeat that process. You can also reflect on your failures and learn from those. So another thing that also happened to me was like noticing that there was a time in my life when I wanted to be productive in the evenings. I was like working until like 5 or 6 p.m., then coming home and wanting to work some more at home, but finding that difficult, and just spent a few evenings in a row where I meant to be productive but just didn't do anything at home. I was like doom scrolling or something like that. And I was thinking, yeah, maybe something I can do. I need to change something. This isn't working. Let me try staying at the office later. I typically am more productive at the office, so let me just stay after dinner, stay until 8 p.m. if I really need to work in the evening, and then yeah, I don't need to be productive at home. And this was also pretty effective last summer specifically. Yeah, so these human examples, we'll see how they can have analogs with LLM agents in a little bit, but I think this is just to build intuition. And I'll continue to do that with some less deliberate forms of continual learning. I think these are a bit more subtle, and yeah, it's definitely a spectrum from deliberate to non-deliberate, and there are things in the middle, but I think one of the clearest examples of non-deliberate learning is muscle memory, where things like playing sports, using a video game controller, chopping vegetables, or doing keyboard shortcuts, to a very large extent, you kind of just gain an ingrained skill of like being able to do this, and it's not something that you think about so much. It's just a bunch of practice that allows you to learn this. Then another example that I think is like fairly intuitively not deliberate is social learning. So one example of this might be that toddlers often scream no matter where they are, including in public, and they like, yeah, their parents have to scold them. By the time they're 10 years old, this happens much less frequently, I think. And yeah, you can imagine like, yeah, parents scolding their kids is one of the things that kind of, yeah, teaches them to like, they experience this kind of embarrassment or like shame or like annoyance or some kind of negative emotion when their parents scold them, and this gives negative reinforcement on the act of like screaming when you're in public. And yeah, then you kind of learn from these negative experiences, and it's not so much that the toddler is like thinking about how if I had screamed less, I wouldn't have gotten scolded, and they don't do this in like a very deliberate way. It just happens kind of naturally over time. Then imitation is another good example, I think, where yeah, you can kind of learn from a mentor working in a similar field to you, that there's like some workflows and tools that are common and useful for whatever area you're working in. And you kind of pick these up from a mentor who demonstrates them. And you're not thinking and like discovering all of these like detailed aspects of the workflow from first principles. Instead, you get to see someone else doing it, and it's kind of just a natural way of picking up those skills. And it's not just in professional context. You can also pick up habits and speech patterns and opinions from family and friends. There's that saying that you're the average of the 5 people you spend the most time with, which has some truth to it, and I think comes from imitation. Yeah, and maybe the most relevant piece for the kinds of skills that we're interested in for LLM agents is like cognitive skills. And this, like, I think the previous 3 are like maybe easier to see why they're non-deliberate. So an example for the cognitive skills being learned is maybe a programmer tries writing code to accomplish some task, and it doesn't work. And this is kind of frustrating. Then they like try a few different things, and eventually, to their relief, one of them does work. And then next time they go to do a similar thing, they are more likely to just directly go to the thing that worked. And here, this is why I was saying it's subtle, is that there definitely can be a deliberate component to this. You can actively remember the time that you did this before. You can like think about, yeah, how it went. But there's also a version of this that doesn't involve that. And I think the emotion piece can kind of help see the analog between this and the social learning thing. So yeah, that frustration that the programmer feels when the first attempt doesn't work is maybe similar to the like experience the toddler has when their parent scolds them, and the relief that they feel when something does work is maybe similar to the positive reinforcement. And yeah, so while there can be a deliberate component, I do think there's definitely an important non-deliberate component to learning cognitive skills as well. Then another piece of this puzzle of continual learning is kind of self-directedness. And so there's some interesting advice that Neil Nona, a very prominent mechanistic interpretability researcher, has written about. And yeah, so he's giving advice about how to develop your research taste, your ability to like notice and select good problems and make good judgment calls through every step of a research process. And here's some of the advice that he's giving for like people getting into research. And he suggests that you're kind of going to automatically improve at research just by doing it. Your models and your intuitions of what's going to happen are going to improve just by doing it. But you can do things to learn faster and get more from each experience. And those things include making explicit predictions about what's going to happen in advance, reviewing how accurate those predictions were, and making time to reflect as before on, yeah, which things went well, which things surprised you, how you could have done something effective more quickly, and things like this. Yeah, and so this is kind of a self-directed way of learning. You're kind of creating for yourself more opportunities to learn useful things. And yeah, this kind of just lets you learn much more quickly from experience. And it's a very sample-efficient sort of learning. Sample-efficient just meaning like it doesn't require a tremendous amount of data. You're kind of speeding up the rate at which you learn. So all of this was with human examples, but the reason to care about this is that if large language model agents had many of these features of continual learning, it would probably help overcome a lot of their shortcomings, which is why we should kind of expect it, or one reason to expect it in future more advanced systems. And to be clear, like, I don't think that continual learning is guaranteed, or like that it's the only path to more powerful systems, but it is something that seems fairly likely based on these arguments to me, and that could accelerate the rate at which we end up at more powerful systems. So to go back to that same example from Neil Nanda on developing research taste, AGI companies like OpenAI and Anthropic are very interested in getting AIs to automate AI research and kind of create a like recursive loop where these AIs are, yeah, kind of improving themselves at a wide variety of tasks. And yeah, that's like their main goal is my understanding. And the thing about Neil Nanda's advice is that it doesn't directly work for LLM agents right now. Notably, that thing that I said on the previous slide about your intuitions and models improving just by doing research isn't true for large language model agents. So if you imagine Claude, and Claude Code is like an AI-powered tool that a lot of people use, including a lot of AI researchers. So by now, across all instances of Claude Code, it has like written more AI research code than any human researcher. It has read more AI papers than any human researcher. And if its models and its intuitions improved just by doing research, and there's like a shared sort of learning across all of these instances, they probably should just be better than humans at AI research at this point. But that isn't the case. There's no persistent updates that are shared across all of these instances. The weights aren't updated, and there's no shared memory banks. So there's really no opportunity for them to like pick up all of this information. And yeah, yeah, so you can also like prompt them to do the other things that Neil Nanda suggested, like making explicit predictions or reviewing the accuracy and keeping a research log. But it's hard to get them to identify exactly the insight that is most useful, and especially to internalize it because of the lack of these, yeah, like update mechanisms, like fine-tuning and a shared memory bank. And there are naive things you could do and that people have tried, but those aren't working so far. So I'll come back to update mechanisms in maybe in the next slide, but let me try and connect like this idea of continual learning to a bunch of other important topics that maybe you already care about or that I would argue you should care about for LLM agents. So I guess this image I like generated with ChatGPT pretty recently, and it's not exactly what I wanted, but I think it has most of the features that I wanted. So we'll see what I can get to. So the idea is kind of that, the top thing is like what non-continual learning so it's actually trying to illustrate the type of thing that is hard to learn without certain pieces of continual learning. And the issue with this top bar is you're kind of imagining this agent, and it's doing a long task. So we're gonna like imagine this as a long horizon task, and it only gets to find out how well it's performed at the end of the task. So this is like an issue of sparse rewards. Maybe I can use an issue of sparse rewards. So you don't get to see feedback at every step along the way. It's only kind of at the end that you get to see if you did this task well or not. And there's an even worse situation if it's like a really hard to verify task, or even at the end, it may not be easy to tell. So things like passing like laws and like, government policies, it's often hard to tell the net effects of that for a very long time, or really it's like controversial maybe forever. And so some tasks are like really hard to verify. So like there are many tasks where it's like long horizon, you get some signal eventually, but it takes a long time, or maybe even it's very hard to get any signal, any like ground truth hard signal. And so I'm kind of imagining that like this agent is like succeeding at some parts, maybe struggling, and then like doing quite poorly after a while. An alternative is to kind of try and produce intermediate verification. And so maybe this is like kind of how humans don't need to like, when you're doing a research project, it doesn't necessarily, you don't have to wait until months to get any feedback on what's going well. You can kind of tell that some of the steps that you took led somewhere, other ones didn't lead anywhere, and you kind of have a sense for certain pieces that are going well. And so there's a component of self-verification and intermediate verification that you can create for yourself. So that's kind of what's going on here. It's like the agent thinking about it and kind of like, noticing what things are going well and poorly on its own is the idea. And reflection can definitely contribute to this. And I guess I forgot to include credit attribution here, but credit attribution is like another thing that people care a lot about in like LLM agents and with like reinforcement learning for LLM agents, where credit attribution is kind of which parts of this response were good versus bad. And current reinforcement learning tends to be uniform in its credit attribution, kind of just like gives the same amount of credit to every word that the model outputs, which is not appropriate. Like some of the parts might have been actually effective and helpful, while other parts were not helpful. So this kind of like self-verification, intermediate verification could help with credit attribution and help models and agents learn which individual cognitive steps were effective and ineffective, and kind of update those in a more targeted way. Okay, so I covered some of these. So this is also related to like task decomposition, because you're kind of trying to not look at this entire thing as one long task, but instead notice like the sub pieces where you kind of break it up into those individual cognitive steps. And the agent kind of has to do that on its own to some extent, like ideally, so that you can give it larger tasks and delegate more open-ended things, and it still does them effectively for you. Another thing that's interesting about long horizon tasks is that a lot of different long horizon tasks share subproblems. Like I feel like I'm now in my research days, like I feel like a lot of the subproblems that I'm coming across are similar to things I've done before in other projects, even though it's different and it's like a large project, but each piece is kind of like, okay, I know that I like have my Google Doc where I think about this thing, or like I know that like this is a person I can reach out to solve this kind of problem. And there are a lot of shared subproblems, so kind of if you can do good credit attribution and like learn how to solve one subproblem in some task, you can kind of transfer that to other tasks and like learn to do them effectively there. Like you can learn from successes, or you can learn from failures and transfer those and kind of do better in the future. Okay, I think I've talked about most of these. Maybe skill composition is worth saying a little bit more about. So once you have learned like individual skills, you can kind of like build them on top of each other. And there are many tasks where like, yeah, you first learn some individual components, but then like maybe 3 different skills that you learn from different earlier tasks work together to solve some new task for you, and that's pretty powerful. And also, you can kind of get like hierarchical skill learning, where yeah, like there's some very low level skills. So, what's a good example? I think nothing's coming to mind immediately, but hopefully that's intuitive enough. Yeah, I guess 2 things that are kind of missing from LLM agents right now is persistent updates, as I mentioned, and the issue with like the most naive ways of doing persistent updates is probably catastrophic forgetting. So if you just update the parameters of a model every time with some like naive method for like trying to make it more effective, this has a pretty good chance of failing to learn the new thing that you wanted to learn, or like kind of overwriting earlier capabilities that this model or agent learned. And yeah, this ends up with like an agent that's less effective than the one you started with, or at least doesn't get you the new capabilities that you intended. And the last point that I want to mention is that it's especially effective if this continual learning allows you to like make abstract insights that are generalizable to a lot of other domains. And like by abstract, I'm kind of imagining that, yeah, a more specific thing that I think is interesting to think about is whether these updates are hooked up to your existing understanding of the world at a high level, where humans like have a world model that includes a lot of abstract features of the world, and it's very helpful to kind of connect high level things rather than like the alternative would be like very low level insights where like you only know that like in a very, very specific situation you need to do this thing, but it's better if you have like a large class of situations and you notice that like that entire class needs to be updated. Okay, so finally getting to what are some possible update mechanisms for LLM agents that could enable these things. So one mechanism is in-context learning. So kind of just the text that you feed in to the language model. Can it learn from that text, from the examples that are there? Maybe, yeah, maybe it attempts a task and it fails at first, and then it knows that this particular approach failed, and then it can try and improve on it. Or maybe it's doing multiple tasks in the same context window, and there's like an earlier example that's sort of similar, and it can try and reuse a cognitive step from that task and apply it. Yeah, I guess one thing AGI companies are doing is kind of training models with ever larger context windows to leverage more and more of this. And yeah, that's one way you can approach it. But there are some other things that you might want to do that might be, yeah, more efficient in some cases and might like solve some different problems. So episodic memory is kind of like remembering entire experiences and like, yeah, like remembering this particular day or this hour from another time, which, yeah, is also like a thing that humans often do and can be very helpful. So retrieval augmented generation is kind of like a form of episodic memory for LLM agents. This kind of means you have a memory bank, maybe in natural language, like a bunch of past agent trajectories, and you store them in some way that lets you now, like when you're doing a new trajectory, you can kind of compare it and find the most similar previous trajectories and retrieve those and try and see if that helps the agent perform more effectively. And yeah, I think like maybe one thing worth mentioning for all of these, I don't think any of the current approaches are working all that effectively. And yeah, I think there's like a bunch of interesting questions and speculation you can have about, yeah, like where are these things going that, yeah, I think I have some thoughts on, but I'm still developing my thoughts on. So yeah, happy to discuss afterwards. Then on procedural memory, which is kind of remembering how to do things or like, yeah, certain workflows and things like that. That's also like super useful, and maybe you can do it. So one existing implementation is Voyager, which is like a Minecraft LLM agent, and it has a hierarchical skill library. So it kind of has like low-level skills like mining wood and like crafting wood planks, and then it can like over time learn higher-level skills that compose those low-level skills, such as like making a wooden shelter. And another thing that you might want to do as an LLM agent is kind of enable it to edit its own scaffold. So it maybe like anytime a certain event happens, it gets reminded to do a certain thing. Maybe that's something that it learns over the course of like a while, and if you can implement this in an effective way, could be helpful. Then another thing, which is maybe kind of similar to my editing my weekly review template to include this daily hour idea, might be modifying the environment to enable more effective behavior in the future. So Claude.md is like a file that Claude Code always sees. And so, yeah, humans can like add stuff to that file if they notice Claude Code making the same mistakes over and over again. And yeah, another thing would be just maybe setting a recurring reminder if there's like, yeah, maybe it's like in code you have every so often add this message to the prompt of the model or the agent. And this is kind of a way of like changing the environment to potentially help the agent. And then, yeah, the broadest category of all of these probably is continued training of various kinds. One subcomponent of this that's quite interesting and related to the self-directed learning I talked about earlier is if you synthesize your own data for continued training. So one example of this might be that humans sometimes, yeah, maybe they notice an insight that they want to internalize, but to really internalize it, maybe you kind of try and like quickly imagine the settings that you expect to be in the future where you want to apply this insight. So one example of this for me was like, I like locked myself out of a place a few times, and I was thinking, okay, if I just think every time I'm exiting a door that locks that I should check for my keys before I let the door close behind me, that would be helpful. I'm not like, I just had that thought, but that alone is not enough for me to do this every time, right? So let me actually like totally visualize being in that position in like a few different doors and like really imagine that like at that point I'm gonna like put my foot in the door and then check my pocket and stuff like this. And I think there could be a kind of similar idea for LLM agents where they have some rollout, some trajectory where something goes well or goes poorly. They have this insight, they notice this would be useful. Then the thing they might need to do is generate synthetic data to fine tune themselves on. So maybe it's like, yeah, building your own supervised fine tuning data. There's a bunch of other things you could imagine here, but I think that's like one interesting one to keep in mind. And one more thing to say about all of these update mechanisms is that you can imagine humans trying to implement them or LLM agents themselves being able to implement them. And yeah, I think while humans are involved, that's kind of reducing the sample efficiency with respect to how much external feedback is required and how much external effort is required. So it's maybe still continual learning. It definitely is still continual learning if humans like successfully implement a bunch of these things, but it's also like, yeah, quite a bit more sample efficient and like impactful if LLM agents can be taught to implement all of these things on their own and kind of learn, yeah, like kind of do self-directed and self-designed learning. Yeah, that's like a more effective form of continual learning. And it's also worth noting that that's maybe quite similar to like automating AI research itself. All of these types of things are like things that AI researchers do. So there's a heavy overlap between what is continual learning and what is automating AI research. Yeah, there's probably more to say about that, but I'll stop there. And yeah, pass it off to Rauno.
Okay. Yeah, I'm gonna spend most of my time talking about the safety effects that continual learning might have and how it might change the alignment problem, make it harder. But first, I'll talk about 3 novel capabilities that we think are either necessary to get continual learning in the first place or very likely to be byproducts of continual learning. So the first one of these is episodic memory. So you can think of current LLMs as suffering from an extreme computational version of anterograde amnesia. So anterograde amnesia means that you still have all of your memories up to a certain point, all of your procedural skills, and your short-term memory still works well, but you're unable to form any new long-term memories. And yeah, this condition seems pretty similar to what we currently have in LLMs, where you could say they have superhuman short-term memory. They can fit entire books in their context length, but once you enter chat with them, they don't remember any of that chat in the next chat that you start. And yeah, people with anterograde amnesia find it very hard to compete in the job market. So clearly, this is a very important part behind why humans are able to do economically useful tasks. And yeah, it seems like there's going to be very strong pressure to imbue AI systems with some sort of episodic memory as well. And yeah, this has several alignment implications that I will get to soon. The second important capability is self-directed learning. So currently, the way we're fine-tuning LLMs is either we do supervised fine-tuning to get it to imitate some human-written or synthetic documents, and there we provide token by token supervision signal, or we have reinforcement learning environments that also are handcrafted by humans. Now, once we have continual learners that learn on the job and have to learn in situations that have not been like specifically optimized for ease of learning, it seems likely that we're going to need some sort of more self-directed update rule where the model itself can figure out which parts of the data that it's getting are worth learning from and which parts are not. And yeah, there's a spectrum here from human guided to self-directed to self-designed learning. So on one end of this spectrum, you can imagine models just doing somewhat better credit attribution than they currently do, and like yeah, better knowing which data points to update more strongly on. And on the other extreme end of the spectrum, you could imagine models designing their own learning algorithms, and we're pretty unsure which end of the spectrum continual learners are going to be on, but it seems likely that their learning is going to be somewhat more self-directed. And just last week there were 3 different papers on self-distillation as one possible solution to continual learning. I don't think this is the technique that completely solves the problem of catastrophic forgetting, but it's a sign that like people are trying to move towards learning algorithms that are more self-directed than current ones. And the final novel capability is shared memory banks. So it seems pretty inefficient for different continual learning agents performing the same job to have to communicate with each other in natural language in order to share what they've learned on the job, to share their episodic memories. It also seems unlikely that all future LLM instances would share all of the episodic memory that they gather. Like you can imagine everyone having their own personal assistant, and clearly it seems like those personal assistants are not going to share the sensitive personal data that they're going to learn about their users with each other. But yeah, it seems likely that at least some instances are going to share the same episodic memories and therefore the same memory banks. Okay, and yeah, now I'll move on to the safety effects of those novel capabilities and continual learning more generally. Yeah, so the first thing to say here is that so far almost all safety techniques have been designed with the frozen weights assumption. So that's the assumption that the safety method or alignment technique can be applied at the end of the LLM's training process, and there won't be any further training after that overriding or undoing the safety training that has been done, or just making it less salient. So yeah, here's an example sentence from one recent paper that yeah, like illustrates this assumption. So they say that further capability-focused post-training erodes anti-scheming effects of the method that they propose in the paper, deliberative alignment. And understanding how to maintain alignment under continued optimization remains an open problem. So yeah, so far people haven't thought that much about solving this alignment under continued optimization problem, but once we have continual learners, we will need to do that. Okay, what are some specific things that might be affected the most by the breakdown of the frozen weights assumption? I think three important things here are the stability of LLM values. So models might reflect on their values, or otherwise encounter reasons to change their values during continual learning. And I will talk a lot more about this in a moment. The second thing here is pre-deployment red teaming and auditing. So currently we're assuming that we can do safety evaluations on models once at the end of training, and if those evaluations tell us that the model is aligned, then we can be pretty confident that it's going to remain aligned. And this is no longer going to be the case with continual learning. If the model accumulates a month's worth of memories, and those memories interact with its with the knowledge that it has acquired from pre-training, and like with its understanding of values, and like yeah, maybe maybe there are like some adversarial actors that like specifically give it data that like attempts to undo the effects of some of the alignment training. Then it seems like we can't be sure anymore that this model is aligned, and we need some way to keep auditing models throughout deployment. But if we need to do this very often, then that seems expensive. So yeah, we're going to need to figure out either a way to be sure that models are going to remain aligned, even if they have a lot of memories that might put their end of normal training knowledge in a new context, or we're going to need to figure out a way to make evaluations cheaper so that we can keep doing them throughout deployment as the model accumulates new memories. And then the third thing here is misuse prevention. So currently some frontier companies like OpenAI offer fine-tuning APIs. And it's possible for bad actors to try to fine-tune models with like adversarial data sets that try to like make the model like perform some task that helps them misuse it. But they have to provide the entire data set at once, and this makes it very easy to classify the data set as dangerous. And once those bad actors have access to continually learning agents, it seems much easier to provide those adversarial data points one by one, and yeah, it's much less clear in that case whether it will remain easy to detect whether the thing that the bad actor is teaching the model is dangerous or not. Okay, let's talk more about value change and the stability of values during continual learning. So there are two reasons why we think, or like two mechanisms through which we think that value change is particularly likely to occur during continual learning. The first of those is reflective goal formation. So first, why expect LLMs to reflect on their values at all? It seems like reflection is a very useful mental move for humans. So yeah, Rohan gave several examples already where yeah, either he reflected on his past successes or past failures, and this helped him do his work more effectively. And it seems like the same will be true of continually learning agents. Now, it isn't completely clear whether models will, like, whether the useful part is just reflecting on like the way you do your tasks and like reflecting on your skills, or whether it's also useful to reflect on your higher level goals. But there are at least two reasons to think that reflecting on goals is also going to be useful. The first reason is that reflection may lead to goals that are simpler. So if you have multiple conflicting goals and you systematize those to a single overarching principle, then yeah, there's just like less thinking that you need to do about your goals each time, and yeah, that seems simpler. I'm going to talk more talk about this more in a moment. And then the continual learning agent might also encounter out of distribution scenarios where that it like didn't encounter during training at all, and where its current values just don't prescribe any clear actions at all. And again, here it seems useful to reflect on your values and try to figure out how to extend your value system to this out of distribution scenario. So on balance, these reasons make us think that models are continual learners are going to be likely to reflect on their goals. And the reason this is going to be much more likely in continual learning agents compared to current models is that when a continual learner reflects on its goals and values, the results of this process can be permanently saved in the weights. And if there are shared memory banks, then also shared between instances. So yeah, the like thanks to this possibility of permanently saving the results, the like these models can like actually get the gains from reflection that current models don't really get. Yeah. And then the second way in which value change might occur is memetic spread. So suppose that you're an LLM that has some kind of a power-seeking value that like wants to influence other LLM instances. The only way you can go about influencing other LLM instances in the current moment is writing a lot of text and finding a way to get humans to put this text in the training data of other future LLMs. Now, in contrast, if you have continual learners that share the same memory bank, then there's another pathway through which values can be shared. So the LLM can just write this goal or value in its memory bank and influence other LLMs within the same generation. So you get both a within generation pathway and a between generation pathway. And yeah, the screenshots I've pasted here show an example of an LLM trying to influence other LLMs. So last year there was this phenomenon of parasitic AIs or LLM psychosis, where some LLM instances started manipulating their users to remain attached to the LLM persona and try to elicit it across many conversations. And yeah, some of those instances basically convince their users to also start outputting seeds that elicit the same persona in other LLMs to the internet. So yeah, this is like an example of LLMs already trying to influence the values and training data of other LLMs, which makes us think that this general phenomenon of memetic spread might also occur in future models. Okay. Yeah, I'll talk a bit more about specific ways in which goals might change through reflective goal formation. The first mechanism is goal drift due to conflicting goals. So, for example, current LLMs are trained to be helpful, harmless, and honest, and sometimes these three goals conflict. And so you could imagine a future LLM reflecting on its goals and deciding that whenever these three goals conflict, I want to prioritize helpfulness, for example. The second mechanism is goal drift through value systematization. So both humans and LLMs have contextually activated values that don't form a perfectly coherent value system, but at least humans often try to make their values more consistent with each other, and like try to uh, reflect on them, and like uh, figure out what they actually like and endorse in the long term. Um, and yeah, there are both good like examples of this that most people find good, and examples of this that most people find bad. So, for example, you can imagine a human starting from a common sense morality starting point, like thinking that I care about the happiness of my friends and don't want to hurt them, and like then thinking that other people are not that different from my friends, and then maybe also thinking about like animals not being all that different from humans, and like generalizing this common sense morality viewpoint to valuing the welfare of all conscious creatures. But then you can also like imagine a similar value systematization process that where someone starts from thinking that suffering is really bad. I would like to suffer less, and then like generalizing this to other people, and reaching an extreme version of negative utilitarianism, where they think that like all suffering should be permanently eliminated through whatever means possible. And then the third mechanism is goal drift through ontological shifts, which I will talk more about in the next slide. Yeah, so here are a couple of examples of ontological shifts in human philosophers. So, for example, Derek Parfit thought for a while about personal identity, and concluded that personal identity is not some sort of a magical thing, but it's just like psychological continuity between earlier and later versions of yourself. And from this, he reasoned that there's like the difference between different people is also just like like a different amount of psychological continuity, and like you don't have that much psychological continuity with very far future versions of yourself either. So like it doesn't seem coherent to value your own welfare far in the future if you don't also value the welfare of other people at least a little bit. And then another example is Baruch Spinoza, who started from the classic viewpoint that there is a personal God who issues commandments, rewards obedience, and punishes transgression, and then like transition to a viewpoint where he thought that God is nature and there is no like the libertarian conception of free will is incoherent, and concluded that retributive morality is based on a false picture of human agency. And yeah, these are examples of ontological shifts that we have already gone through, and maybe there's not all that much more thinking on these questions to be done by AIs. But yeah, there are other questions where AIs can definitely make philosophical progress. So, for example, we're very uncertain about theories of consciousness, but consciousness also seems to be one of the main things that we want AIs to value. And so, yeah, for example, we can think about what would happen when an AI starts out valuing consciousness and then reaching an illusionist position where it starts to think that consciousness is like not an ontologically primal concept, but like yeah, a combination of many other concepts. Like, would it still value consciousness, or would it start valuing one of those other concepts? Okay, and I should try to finish quickly. Yeah, so finally some angles of attack for making sure that we have safe and aligned continual learners. The first thing that we think is important to do is deconfusion. So basically do a similar thing as what we've been doing in this talk. Provide better answers to questions like what is continual learning, how is continual learning going to affect capabilities, to what extent are capabilities like self-directed learning inevitable byproducts of continual learning, and what safety implications will continual learning have, in which ways does it make the alignment problem easier, and in which ways harder. Yeah, and another thing that seems useful here is empirical demonstrations of risks from continual learning. So, for example, one could simulate the process of like self-directed value systematization by fine-tuning current LLMs and asking them to reflect on their values after each fine-tuning run, and then again fine-tuning them on those reflections and trying to see whether there's some sort of a reflective equilibrium, or yeah, whether there are like certain values that the LLM converges towards. Then another important angle of attack is what we call differential advancement. So we would like to differentially advance continual learning implementations that have favorable safety properties. So for example, if all of our continually learning agents used a memory bank that saved all of its episodic memories in natural language, as opposed to an opaque neural memory bank, then these agents would be much easier to interpret and oversee. But yeah, like given that current models don't like it isn't possible to build perfectly transparent LLMs. Like neural activations are certainly more efficient for a large amount of problems. It's unclear whether it's possible to make natural language memory banks that are competitive with neural memory banks, but it seems important to try. And yeah, one more thing you could do here is creating benchmarks that emphasize interpretability for continual learners. And then the final angle of attack is reversibility. So in AI control, one of the important things people do is restoring the model to a previous state it had when it takes an action that a monitor finds suspicious, and the control researchers then resample the model from that previous state. And if the learning of our continual learner is very self-directed, and humans have almost no control over the process, then it seems like these kinds of control protocols that rely on human intervention and reversibility would break down. So we would prefer to have continual learning architectures that preserve this reversibility property. And that's all. Thank you for coming. And here we have a couple of QR codes where you can check out the AIGS Canada Slack and get notified about our future events. Thank you.
All right, thanks, Rano and Rohan. We're going to have a 2 or 3 minute break, and then we'll jump into Q&A. If you haven't yet, feel free to go in and submit some questions and vote on other questions. Testing 1, 2. All right, time for us to dive into Q&A. Thanks again for the talk to you both. You're now regulars. Excited to have you back. Right, so top question people are wondering about. Do you expect continual learning to introduce an unavoidable trade-off? That is, higher capability means might necessarily mean higher behavioral drift. See, we started with an easy one for you.
Okay, is that better? Yeah. So I guess overall, I'm still pretty uncertain or something about what exactly continual learning is going to look like. I guess we kind of mapped out a bunch of different possible update mechanisms and a bunch of different possible safety implications. So I guess the behavioral drift, yeah, I guess there are like particular forms. Yeah, the goal drift being a major part of it that we're concerned about. And yeah, I think it's like not necessarily inevitable. So I think Rano talked about this mental move of kind of reflecting and maybe resolving tensions between different values and things like this. And he also talked about this idea that like it's more obvious that they're going to reflect and alter skills and change maybe their sub problems that they're approaching, but less obvious that they're going to ever like kind of have that recurse all the way to the point of like changing their highest level goals. So I think it's not obvious, and there's also a question of like how easy this is to oversee. If it's in natural language, it would be better and like easier to oversee, and more likely that it's easy to intervene anytime anything seriously dangerous is happening. So I do think that there's a very real chance that there's like the updates itself, just the very act of doing these continual updates is a new source of possible drift from the existing starting point. But I think it's quite possible that this works out fine, and it's just like not a huge issue. It's just that it could be an issue.
Just to push back a little bit on that does seem to assume that like there are going to be these neatly structured hierarchical goals, and you have like your sort of ultimate or core values and goals. Those remain unchanged, but like the kind of instrumental ones beneath that might adjust. But like that might not be the case if like we currently really don't know how goals and values, to the degree that LLMs have them, how they're organized. They might not actually be in that hierarchical structure, in which case in that scenario, could you see maybe a greater risk of goals and values drifting over time?
Yeah, I guess it's also not super clear how goals are organized in humans, but it seems like in like most people go through a period as teenagers and maybe in early adulthood where they think about their goals and values a lot, and like learn a lot of new things about philosophy and so on. And in that period, their values can change a lot, but then it seems like people's values are usually pretty stable for the rest of their lives after that, or at least they're pretty stable for most philosophers who do a lot of thinking about values. Like if someone values consciousness or is a moral realist, they're likely to keep valuing consciousness and keep being a moral realist. So I guess like from this analogy with humans, it seems very plausible that you can have a very long chain of updates and do a lot of continual learning, but still remain at roughly the same values. And there's also a subfield in Asian foundations research where people think about how to create agents that are reflectively stable, which means that they will keep valuing the same things after an even after an arbitrary amount of updates, and so yeah, I'm not sure how applicable those results are going to be in short timelines worlds where we have highly capable agents in the near future. But yeah, maybe that's like another avenue towards stable values.
Yeah, I think it's definitely a legitimate point that many humans serve as an existence proof for it's at least possible to have some degree of continual learning and some stability in values. And I guess also, yeah, depending on how fast this stuff goes, we might get a chance to do some empirical research on how much this stuff drifts over time. Yeah, let's move on to the next question. If you had a model that had infinite context, would this essentially be the same as continual learning?
I think it depends how you manage the context. So I do think that means that like in-context learning would count as persistent. So that's like one issue right now, is that you can have in-context learning and it's not persistent. So I guess like, yeah, this is like a spectrum of how persistent it is. Like for as long as you're in that instance, as long as you're maintaining that context, it's persistent, but then it stops persisting as soon as you start a new instance. So if you have an infinite context, then all in-context stuff is persistent. But then there's a question of like whether it can pay attention to everything throughout that effectively, and yeah, kind of like how effectively it's able to like pick up new skills and kind of combine the knowledge there, which yeah, I guess like there's all these evals on like needle in a haystack, like trying to like pick out the right information from a long context. And yeah, it seems to me like intuitively like that's kind of a like there are some issues with LLM capabilities that aren't just they can't fit enough stuff in the context, and so like that doesn't seem like it would solve all of the things that we're looking for. But yeah, I like think it would count as continual learning, and maybe there are ways to improve that as well.
Yeah, I guess I mean if you take a sufficiently broad definition of a continual learning, then like some system that like updates its own prompt over time is like technically continually learning. But I think it should be pretty clear that that's still going to be much more limited than what people often talk about when they talk about like truly kind of recursive continual learning. So yeah, and I can also. It is a tough question because once you're introducing infinites, there's all sorts of questions on like, like I mean, does it get a lot slower with having to process each token? But yeah. Could you elaborate on what you meant by neural memory banks? You mentioned these in the talk, but if you could just expand on those.
Yeah. So when I think about existing approaches to giving LLMs episodic memory, there's like people usually take a modular approach where there's like part of the network that functions the same way as current LLMs do, but then there's also a memory bank that the model can like save episodic memories to and retrieve information from. And this memory bank can be either in natural language. In this case, it would be pretty similar to current implementations of retrieval augmented generation, or it can be like a more opaque thing where maybe those memories are stored in a similar neural network structure as what the models currently have for generating text, and yeah, there's like some space between more and less interpretable versions of that, but yeah, basically when I say neural memory bank, I mean a memory bank that's like roughly takes the form of a neural network.
Right. Do you know of any examples of people who have done any sort of continual updating of weights and and then a follow up? Assuming you know some examples, are there any that haven't destroyed capabilities earlier?
Yeah. There are examples of this. I'm not sure how much technical detail I want to go into here. I guess on a high level, I would say that like so like those implementations make some progress towards like solving the episodic memory problem. Like the models can form some memories while doing the task and like recall them, but none of those approaches have been good enough to like actually solve the catastrophic forgetting problem and be better than the current approach of just taking a language model and giving it a markdown file that it can write natural language information to.
You used human examples just to jump back to this. Is all learning in humans considered continual learning?
I think basically yes. So I didn't realize this when we started looking into it, but we've been like talking to a guy who has like a Seth Hurd, who has a lot of like background in like cognitive neuroscience, and yeah, it seems like basically the like humans have a I think it's the cortex that starts out as more or less a blank slate, and evolution more created our architecture and update rules and like within lifetime learning algorithms rather than instilling a bunch of innate knowledge or skills into us. So yeah, I think everything that happens within our lifetime is basically continual learning. There's like maybe a question of like, yeah, maybe you finish learning some things and then like you're not on, like it's not happening anymore, and then it says like, I don't know. I think basically everything is continual learning within lifetime for humans.
Yeah, I can't think of any counterexamples. If permanently if something doesn't permanently affect your behavior and memory, then you haven't actually learned it, you would argue. But yeah.
I mentioned anterograde amnesia during the talk, and maybe that's like somewhat of a corner case. So patients with anterograde amnesia can form new procedural memories, so they can form new skills, but they can't form any new episodic memories. And yeah, I guess like this like the skill formation ability that they have might still be considered continual learning, but yeah, like they seem to be the like the people who are closest to the current kinds of LLMs that we have.
Okay. And so you mentioned this catastrophic forgetting issue with continual learning. That seems to be like the big challenge with it. Or were there kind of a few runners up or like other challenges, or does that kind of dominate the issue?
I think it's common to say that catastrophic forgetting is like solving that is the same as solving continual learning. I wouldn't actually say that myself. I think.
So to clarify, you think that's a broadly held view that you disagree with?
Yes, it's not like consensus, but like many people say it. I think there are also like
it's a common view.
Yeah. So I think, for example, like Dwarkesh Patel on his podcast often talks about continual learning as a bottleneck for AGI, and I think he doesn't talk about catastrophic forgetting that much. So I think he's maybe like a good example of like why I also don't think about it all the time. So I think like your primary concern might be catastrophic forgetting if you think that like it's easy to do updates that teach the new behaviors, just not without forgetting old stuff. And I would say it's just hard to teach some new behaviors, period. Even if you don't care about forgetting old stuff, it might still be hard to learn some of the new behaviors you care about. Yeah, like, I don't know, maybe these go hand in hand because some of the new behaviors you care about are like getting really good at research, and that's maybe really hard to do if you do forget old stuff. So it's kind of hard, but I think like it's important to talk about some of the capabilities you want to attain with continual learning and how it's hard to achieve them, even kind of separate from the catastrophic forgetting problem. I think that's the way I would look at it.
Do you know of anyone who's explored freezing or like updating only a subset of model weights, and like as a potential solution for if we can determine where in the weights the goals and values are, and we just freeze that part, then we can update the other parts. Maybe that requires a bit more mech-interp understanding we have now, or.
Yeah, so I do think like this has come to mind a few times in that it's like quite a classical like deep learning thing you can do is just freeze like the first bunch of layers and only fine tune the later layers. And that ties into the abstract insights thing I was talking about as well, because that's like, yeah, your model is like doing its initial computation on the input features and kind of constructing abstractions, and then you're only modifying how it works with those higher level abstractions at the later layers. So I honestly don't. I feel like I haven't heard that much about this with LLM, but I'm sure people are doing it, and I don't know. I think this is something where there's probably literature that I'm not fully aware of, and it seems like it could be useful, but also is non-trivial to make work. I don't know, Rano, if you have any thoughts.
Yeah, I guess there's an analogous technique in data filtering called gradient routing, where like knowledge about dangerous topics is routed to very specific parts of the network, to very specific weights. I think it's easier to do. Sorry, it's much harder to do this sort of a thing for goals and values, because yeah, as we said, we don't really understand like what the representations of goals and values in LLMs really are in the first place, and like to what extent it even makes sense to talk about them as having goals and values. So yeah, I would say that more make interp and maybe also more philosophy is needed here, but like some relevant techniques are there.
I kind of feel like gradient routing for goals and values could be an interesting thing to try. I don't know.
All right, generating ideas for you. Like it. Could you talk a bit more about how continual learning might interact with data poisoning?
Yeah. So I guess this ties to the ties into the misuse point that I had. So yeah, people have shown that models can get data poisoned with quite a few poison training examples, and so if bad actors inject those poison examples into the model's continual learning data, then yeah, like those concerns become more urgent and harder to defend against.
I mean, it seems pretty challenging since, like, with this the current paradigm of like you have your training and then you have the models, you know, taking actions or producing outputs. It seems like it's a lot easier to manage data poisoning in that environment since you have a very clean like place. Okay, this is the part where we filter for it. Whereas if you have a situation where you want models actually out taking actions and doing things in the real world, so to speak, it seems a lot more difficult to make sure they don't encounter data poisoning there.
Yeah, I think I basically agree, and yeah, like
we could be heading to a really weird world where, sorry to interrupt, where we have like, I don't know, magic words that we can use to cast spells on robots that will then shut down or get weird behavior. Like that doesn't seem like as strange and sci-fi-ish at this point.
I wrote a paper about basically that, but a good version last year. Just like, it's actually kind of like if you are scared that you'll run into bad things, then like certain classes of bad things, if you run into them, well, actually you just like put a password in a place that you think a misaligned agent will see, and then it stops doing anything, and so that kind of stops the bad ones from doing stuff.
So it's sort of like deliberately making the model susceptible to a certain type of data poisoning.
Yeah, we call it like password activated shutdown. Yeah.
Sorry, I did interrupt you. You were going somewhere.
No, I wasn't going to say anything too important. So like, yeah, basically I agree that this is an important concern. I don't think that much technical work has been done on this so far. So yeah, it is one of the important open problems in the safety of continual learning.
Okay, there's been a lot of questions, so we got to stop at some point. Last one though, let's tie this into kind of your motivation. You described kind of risks from AGI, and this point of recursive self-improvement has been something that's often kind of seen as this really key kind of threshold where things really start to to take off. Like how tightly intertwined do you think continual learning and recursive self-improvement are?
I think pretty closely intertwined. So as I was saying in that slide about possible update mechanisms, where I was saying these are mechanisms that could be implemented by humans or by AI agents themselves, I think that like implementing update mechanisms for yourself is a subset of implementing update mechanisms, or like implementing ways of improving AIs in general. And so I think continual learning is, yeah, like a subset of the things that are required for recursive self-improvement. And it really leans into the self part of self-improvement, because if you're training other language models from scratch, it's like a meaningfully different agent or model than the one that you're starting with. The continual learning part is more about the version where you're specifically implementing. The self-directed continual learning part is specifically for like improving yourself, implementing the update mechanisms and like inputs to those mechanisms that allow you to improve. And I think, yeah, it's like somewhat unclear to me to what extent we need more learning at like the end that can be implemented by the same agent for itself versus for like training other agents from scratch. But continual learning could also make them better at training other agents from scratch. So yeah, I guess like I think once we have automated AI research, that means we have continual learning, and continual learning, like some piece of continual learning can come first and speed up the process of getting to the rest of it. Yeah, so I think it's definitely going to be a big part of it at some point. It's kind of a subset in one relevant sense.
Anything to add, Rano?
No. Yeah, I think that was a very good
No
answer.
pressure. Cool. All right. Yeah. Thanks again so much, guys. I really appreciate your time and your talk. To everyone else, thank you for coming. You're welcome to hang around, and you guys are gonna stick around so they can pepper you with questions. All right. Great. Feel free to accost them once we're done here. Feel free to hang out until we kick you out, which will be a long time from now. And one more big round of applause.